Quadratic equation application problems. We've worked with a number of application problems so far. We know that we want to completely understand the problem, having a clear understanding what information we have to work with, and also clear understanding what we're asked to find. This may involve drawing a table, sketching a picture, just rewriting the information given you on the problem. And a lot of them can be categorized into specific types, which are solved real similar to one another. So once you identify what type it is or come up with a plan and how to solve it, obviously carry out your plan, set up the equation. In this case they'll be quadratic equations, so solve the equation, but also make sure you completely answer the question. Understand what you just found and make sure your answer seems reasonable, including any and all units. So the first type of application problem we're going to cover is going to involve the Pythagorean theorem. The Pythagorean theorem is just a rule that allows you to find the missing side of a right triangle. So first of all, you have to have a right triangle, which is a triangle with a 90-degree or a right angle in it. In order to use the Pythagorean theorem to find the missing side, you have to know the other two sides. So the Pythagorean theorem will allow you to find the missing side of a right triangle as long as you know the distance or the length of the other two sides. The formula is the formula a squared plus b squared equals c squared, where c is referred to as the hypotenuse, which is the side opposite the 90-degree angle. It's also always going to be the longest side of a 90-degree of a right triangle. The variables a and b are referred to as the legs. They're the two sides that form the 90-degree angle or touch it. So since you're simply adding a and b together, it doesn't matter which one you call a, which one you call b, as long as they are the legs, the sides that form the 90-degree angle. So given the formula a squared plus b squared is equal to c squared, we know we can only solve an equation that only has one variable in it, which means we have to substitute values in for the other two variables. So example 1. Read the problem. It doesn't mention anything about a triangle, especially a right triangle. But to organize the information we have, it talks about distance and direction, so common sense says we're just going to sketch out the flight this guy takes. Victor says he flew 700 miles north and then 2,400 miles east. And it's asking us to find how far he is now away from his original starting point. So if we sketch it out, obviously it forms a triangle. We would have to prove that it is a right triangle, though, in order to use the Pythagorean theorem. And basically we can. It's nothing more than the x and y axis set up as basically your north, south, east, west axes. We know that they're perpendicular lines. So if you're going north and then turn east, obviously that has to be a 90-degree angle. So the distance he is now away from his original starting point is the side opposite the 90-degree angle, the hypotenuse. So that's our variable c, what we're solving for, which means the remaining two sides that we know are the legs a and b. So for the Pythagorean theorem, once again, it doesn't matter which one you call a, which one you call b. Substitute those values into the equation, allowing us to solve for c, the hypotenuse, which is obviously a quadratic equation. And the best method we can use to solve this would be the extracting the roots method. Simplify, take the square root of both sides, not forgetting your plus or minus. C is equal to plus or minus 2,500. Like most quadratic equations, it gives us two answers, two solutions, but we have to make sure they both seem reasonable. Our two answers, positive 2,500 and negative 2,500, possible distances he's away from his original starting point. Well, obviously he can't have a negative distance, so the only reasonable answer would be the positive 2,500. Include your units, miles, and make sure it seems reasonable. We said the hypotenuse has to be the longest side of a right triangle, and it obviously is. The next example is probably about the most common example associated with quadratic equations, a projectile motion problem. We're familiar with the graph of quadratic, so in a projectile motion problem, what's going on here is an object that goes up into the air, and as we know, what goes up must come back down. So for instance, if we launch a rocket up into the air. If we follow the path that rocket takes, the path it takes forms the shape of a parabola, more specifically a parabola that opens down, or at least a piece of a parabola. If this is the ground here, obviously when it comes back down, it's not going to keep going down into the ground like a parabola technically does. So we're just taking the piece of the parabola above the ground, and that horizontal line that represents the ground would be nothing more than the x-axis. So in order to work and solve a projectile motion problem, you have to know the basic formula. H of t is equal to negative 16t squared plus v sub o t plus s. In other words, this basic function has four unknown values. T, which represents time in seconds, time after the object is launched. V sub o, the initial velocity, the initial speed at which the object is launched. S is the initial height where it's launched from. And h of t is the height after t seconds. So this function here has four unknown values, and we're only allowed to solve for one, which means we have to substitute in values for three of the four. So read the problem, example 2. We should all be able to easily recognize this as a projectile motion problem. So what we know about the problem, first of all, that 75 is the initial height, the initial velocity, 75 feet per second. We know it's launched from the ground, so the initial height then is simply 0. At what time or times, so it's asking for time, so that's what we're solving for t, which means we have to substitute something in there for h of t, the height after a certain amount of time, and that's exactly what we're asked to find. How long will it take for the height, for the object to reach 70 feet? So substitute these values into the function. 70 is equal to negative 16t squared plus 75t plus 0, which obviously gives us a quadratic equation now with only one variable which we can solve. Set it equal to 0, and obviously you would want to use the quadratic formula here, especially since it's telling you the rounding answer to one decimal place is probably going to be a pretty ugly answer, probably not factorable. So set up this problem. T is equal to negative 75 plus or minus the square root 75 squared minus 4 times negative 16 times negative 70 all over 2 times negative 16. So it should give you two answers. The first one, rounding to one decimal place, t is equal to 1.3 seconds. The other one, t is equal to 3.4 seconds. So understand what we just found. We found two solutions to this quadratic equation, two possible values for t, which is the time that it would take for this object to reach 70 feet. We'd have to make sure they're both reasonable. An example of an answer that would not be reasonable would be a negative answer. Obviously time wouldn't be negative, but in this case we have two possible answers, and they both are reasonable. So since there's two times that it takes for this object to reach 70 feet, what it means is that it's going to reach 70 feet on the way up after 1.3 seconds, and then it's going to hit 70 feet on the way back down after 3.4 seconds of being launched or thrown up in the air. So two answers, they both answer the question, so you'd have to have them both. Now solving a quadratic equation, we know two real numbers, as we just found, is a pretty common outcome, but we could also have one real number, one real solution. If that was the case, we solved this equation and only came up with one real answer as to how long it would take the object to reach a height of 70 feet. That means that would be the maximum height. It would reach 70 feet at the vertex, wouldn't go any higher, and that would be it. One solution, one answer to that problem. The third possible outcome for solving a quadratic, we know, we could have no real numbers. In other words, two imaginary complex numbers. So the way that would tie into this problem, if you were trying to find how long it took for the object to reach 70 feet, we know time cannot be an imaginary number, which means the object would simply never reach a height of 70 feet. So therefore, no answer, no solution. So projectile motion problem. The next type of application problem is a geometry problem, which we've covered before. Simply a problem that involves some sort of geometric shape. So in this case, we have a triangle. So the best way to organize one of these problems is just to sketch out the image, we know any triangle, whichever type you sketch, whatever it looks like, is made up of a base and a height. And in this particular problem, it says the height is 3 centimeters less than the base. So if we let the base represent b, the height then we can represent as b minus 3. It goes on to talk about the area of a triangle, so you have to know the formula for area of a triangle. Area is equal to 1/2 base times the height. So if we substitute in the area what we're given in the problem, 26, we let the base represented as b, but we put the height as base b minus 3. Now we have an equation with only one variable that we can solve for. Simplify a little bit. Distribute that 1/2 b, so 1/2 b squared minus 3/2 b. We see that exponent of 2, so quadratic equation. Set it equal to 0. And you can certainly solve this quadratic using the quadratic formula in this form. Or you could clear the fractions as we discussed earlier on in the course. Multiply through by the least common denominator 2, which gives us b squared minus 3b minus 52. Either way, using the quadratic formula will still give you the same answer, which in this case would work out to be b is equal to 8.9 and b is equal to negative 5.9. So two possible answers for the base, which is obviously the side of a triangle, which cannot be negative, so we have to get rid of the negative 5.9, which leaves us the base 8.9 centimeters, and if the height is 3 centimeters less, it becomes 5.9 centimeters. And the next one, a maximum or minimum problem. Well, we know quadratic equations, primarily their graph, the parabola, is either going to open up or down, which means they'll either have a maximum point or a minimum point. If it opens up, it'll have a minimum point at the vertex. If it opens down, the vertex will be a maximum point. So anytime you hear the words maximum or minimum, there was a key word telling you you want to or will be working with the vertex. Now in this case, we do not have to come up with a function or a quadratic equation. We're given the function, we just have to understand what it stands for. X is the number of hot dogs sold, P of X is the profit. So obviously he wants to maximize profit, and what we know, when A is negative, it's going to open down, which means that vertex obviously will be a maximum point. So we don't have to find the entire vertex, because the problem is simply asking how many hot dogs does he need to sell in order to maximize his profit. So number of hot dogs was X, so all we have to do is find the X coordinate of the vertex, and given this quadratic function in standard form, which we know we have our little formula for that, negative b over 2a. So negative 78 over 2 times negative 1 simplifies to just a positive 39. So in order to maximize his profit, he would need to sell 39 hot dogs.